Non-equilibrium molecular dynamics, or NEMD for short, is a commonly used tool to study phenomena such as friction and wear in tribochemical systems. In this video, the procedure for setting up an NEMD simulation is demonstrated, with the goal of calculating the friction coefficient of two sliding quartz surfaces using the reactive force field ReaxFF. The structure consists of two slabs placed on top of each other. The slab on top will be sliding over the slab at the bottom. To control the external forces applied during the NEMD simulation, different regions are assigned. The sliding slab and the bottom slab are defined as two separate regions, labeled A and B. Additionally, the silicon atoms in the bottom layer of the stationary slab are assigned to a region called fix, allowing them to be locked in place later. All atoms other than the fixed ones are placed in a region called free, enabling them to be thermostated at 300 Kelvin. To set up the external forces and velocities, the NEMD panel is used, where the previously defined regions can be selected from a drop-down menu. For this demonstration, a velocity of 0.0005 angstroms per femtosecond, equivalent to 50 meters per second, and a normal force of 10 nanonewtons are applied. These forces act on all atoms within their respective regions, and these atoms are excluded from any thermostating. In the MD trajectory options panel, right engine gradients is selected, as the gradients are required for calculating the friction coefficients later. Next, standard MD settings such as time step and thermostat are defined. These details are skipped in the video for brevity, but the complete input file is available in the video description for those interested. Once the calculation is complete, the trajectory is opened in AMS Movie, where both the normal and friction forces can be visualized. The Z-force is shown to be close to the requested value of 10 nanonewtons, while the friction force oscillates in cycles of about 12 picoseconds. Averaging over each cycle is necessary to obtain a reliable friction coefficient. To calculate the friction coefficient, a small script located in the home directory is used. For viewers unfamiliar with running scripts in AMS, the video description contains a link to the appropriate documentation. By passing the block variable, the script averages the forces every 12 picoseconds, matching the frequency of the fluctuations observed earlier. The resulting average forces are then used to compute the friction coefficient. That concludes this demonstration. Make sure to check out the links below the video to learn more, or try it yourself with our free AMS trial. Thanks for watching.